today's work is dividing rational expressions.
And that's why I go with rational
Sure. Okay, and what I hope that you can say that you can do at the end of this is that I can divide rational expressions I don't know why I decided to capitalize the expressions. I guess I'll be consistent here. I feel like you guys are one of those mystery capitals. I'm just going to throw it in right here. I don't know why expressions is capitalized, but it is. Anyway. And then I want you to use dimensional analysis. With divisions. So dimensional analysis is very similar to those problems that we were just doing on last night's homework. However, now we're going to be using that same thing with division. Okay? So dividing rational expressions. That's what we're looking at. And when we talk about dividing rational expressions, we want to first think about what we know about dividing fractions. What do we know about dividing fractions? What did we already learn about this in 5th/6th grade? Austin?
You have to do same change flip.
Same change flip. Yeah, some people do it. There's a lot of people who do it different ways. I like to, since we use at this language, same change opposite, same change flip, using that same sort of lingo, the same sort of lingo that we do with anything else. Let's do same change flip in this case. Okay, so just like addition is related to subtraction, multiplication is related to division. That's why we can use that rule. Anyway, same change flip. So we've got same, 1/2, change, let's change it to the sign, multiplication, and flip. And then what do we know about multiplying fractions? What do we know about multiplying fractions? Jasmine? We multiply straight across. So Braden, what's that equal?
7/10.
7/10. And I actually think that multiplication of fractions is easier than addition and subtraction because you don't have to make the denominators the same. You could, but you don't need to. Otherwise, you're going to have a fraction that is not simplified. But you don't have to make the denominators the same. All right. So knowing that, it follows the same rule with any rational expression. That includes rational expressions with variables. So let's look at the example that is given to us in the book. 5x squared over 7 divided by 10x to the third over 21. Okay, so we're given this example in the book. So what's the first thing that we should do? Same change flip. Same change flip. So we take first expression, change the sign to multiplication, and flip. That's cube squared. I'm going to read my own handwriting. That is cube. Okay. So now that I've same change flip, now what do I do? Yeah.
You can either cross multiply, or if you wanted to, you can actually, you could do kind of like simplifying that.
Yeah, if I wanted to, I could multiply straight across 21 times 5 and 10 times 7. However, at this time, it's way easier to simplify right here. It's way easier to simplify here and look for common denominators. Like in this case, the 5 goes into the 10. They both have they both have a factor of 5, so this would be 1, this would be 2. 7 goes into 21 3 times. X to the third and x to the second, that just becomes x to the first down here. So then now I'm simplified. Now I've got 3 over 2x. And that's, I think, a lot easier than doing, what's that, 105. Is that right? 21 times 5, 105 over 70. I just, x to the second, x to the third. I'd rather simplify up here like this than trying to simplify that myself. But that's just me. Let's see. Let's try the other. I want to. You know what I'll do? I'll have you try one on your own. 6x to the 4th over 5 divided by 24. Yeah, where'd it go? There we go. 24x over 75. I want you to try that one on your own. All right, let's take a look at these. What do I need to do first? Here? Alec.
Same change flip.
Same change flip. Okay, so I'm going to do same. Change. Flip. Now what do I need to do, Braden? Simplify. Okay, how am I going to, what do you mean by that? I like to write like this. I like to write x to the 4th times 75 over 5 times 24x.
24 and 6 have a common factor.
Okay, 24 and 6 have
So
a common factor of,
6.
oops,
So it'd be
1, right? What would that be?
4.
Good.
4 then 5 and 75.
5 and 75,
Common factor of 1, 15.
15.
And then x. So you can take away 1x, so it's x cubed.
So it looks like we have then 15x cubed over 4. Cool. Okay, well, feeling pretty good about that? All right, well, let's look at the next example. That's just expressions involving monomials. Those are all monomials. Now we're going to look at binomials. Okay, so binomials are n plus 1 over n plus 3 divided by 2n plus 2 over n plus 4. All right. What do you think we're going to do here? What's our first step here? Okay, what's our next step here? Austin? Same change flip. Yeah, so let's just take this. I'm going to do a little magic trick here. Huh. It's magic, man. I have a plan. He sure doesn't know his man. Oh, darn. Can I just take it and flip it? Wait, I wonder if I can fix this. Can you fix it? Not really.
Just reverse it.
Upside down, reverse it.
Flip.
U E.
Up, down, up, down.
Up,
Well,
Ah!
no, I don't know.
I don't even know where it was that we were doing. I got an idea. How about we look back at the book and flip it? It was
That's not interesting.
2n plus 2. What was that? Alright, a little blip in this. Alright, so I magically flipped it. I just flipped the flip of a switch, I flipped it. Okay. So now what do? What do you think I'm going to do now? I've got some binomials up there. What do you think I'm going to do now? Anyone have an idea? Brandon? What do you mean simplify? Finding the greatest common factor. No. Now, you might say, hey, I've got a 3 here or a 4 here and a 2 here. You can't simplify like that because this is related n plus the 4. It's not a 4 just on its own. We don't know what n is. So you can't simplify those because it has to first add to the n. Okay? Samantha? Excellent. Excellent. So in this case, we're going to take n plus 1 over n plus 3. Now, if the binomial is exactly the same, then we can cross them out. That's how we can simplify. And I'm going to come back and show you why we can't do what you were saying. Okay? It's a common mistake, but if you understand why you can't do it, then you won't make that mistake when it comes like test time or in the future. But here, n plus 1 and n plus 1 can cancel out. Because think about this. Let's think about n as being 5. 5 plus 1 is 6. 5 plus 1 is 6. It doesn't matter that it's 2 times that. 6 divided by 6 is 1. So that's why those can cross each other out. Whereas here, let's pretend n is 5. 5 plus 1 over 5 plus 3 times 5 plus 4 over 2n plus, 2 times 5 plus 2. So what you did is you said cross that 2 and that 4 out, right? So that's 5 over 10. And you see why you can't do that? That makes this 5 plus 4 is 9, where 2 times 5 is 10 plus 2 is 12. Well, you just made, that was 9 over 12. Now you just made it 5 over 10. You see the difference? And that's key, is knowing, can I actually cross those out? In a monomial, if it was 4n over 2, then you could cross it out, because monomials, when they're just dealing with multiplication and division, then you can cross out. But when it's addition and subtraction, or monomials, you can't cross it out. Okay? That goes for everyone. You simply go back and substitute in if you can't remember the rule. You can almost teach yourself the rule. Okay, so now we're left with n plus 4 over 2 times n plus 3. And you can, if you wanted to write it out in expanded form rather than factored form, that's fine. I don't care which one. Okay? All right, so now I want you to try one. I want you to try 3m plus 12 over m plus 5 divided by m plus 4 over m minus 2. Don't forget about your first step. That's the key part here, is your first step. So first thing we do here is same change flip. Okay, so I'm going to take and I change this to m minus 2 over m plus 4. Did I do that right?
Yeah.
Did I flip it?
Yeah.
Okay, cool. And I change that to multiplication. Then I factor out a 3 in the top. Go ahead. All right, so we've done our same change flip. Now we're going to factor out, look for any common factors in our binomials. And in this case, I can factor out a 3, which leaves me with m plus 4 over m plus 5 times m minus 2 over m plus 4. The binomial m plus 4 cancels out, and we're left with 3m minus 2, 3 times m minus 2 over m plus 5. If you want to distribute the 3 through the m minus 2, you may do so. All right. Now, we can also divide by a monomial. So if we have 5a plus 10, 5a plus 10 over, actually let me do the one that's in, let me do, this one is an example in the book. In this case, I'm going to do just one. 12x minus 36 over x minus 7 divided by x minus 3. What do you think I'm going to do here? Ben?
You'll put the x minus 2 over 1.
X minus 3 over 1. It really is a fraction, right? Yes.
And then if that when you do same change flip, then it'll become 1 over x minus 3.
Good. So you take the same thing and you're going to do times 1 over x minus 3. So we flipped it. Okay, we simply flipped it. Yes, ma'am?
And then you would factor the 12x minus 36.
Good. So here I'm going to factor a 12 out of 12x minus 36, and I've got x minus 3. Now what am I going to do, Jenna?
X minus 3 both cancel each other out.
Good. And then we're left with just 12 times 1, which is 12, over x minus 7. Okay. Finally, our last example is expressions involving polynomials. So I'm going to give you an example of q to the second minus 11q minus 26 over 7 divided by q minus 13 over q plus 7. Those q's look like 9s. Okay, what do I do first? Yell it out!
Same change opposite.
Yell it out.
Good. So I just changed this to a multiplication, and I'm going to do. Would you stop? does it look like 9 to the cube? Yes.
You need to know what a variable is. You know what I do? I just put a line under it,
Okay.
a small line, because that's how I know it's a variable.
Cool. Sometimes I change mine to a variable that's easier to use, like maybe H or something. It doesn't look like a number. So. And then at the very end, I change the variable back. All right. So I did my first step of same change flip. What do I do next? What do you think I do next? Logan? Okay, so we factor that, right? In fact, simplify it's factoring it. So, anyone know what multiplies to negative 26 and adds to negative 11? Lucas. 2 and negative 13. All right, so we have Q plus Q minus 13, Q plus 2. So in this case, our Q minus 13 and our Q minus 13 simplify. We're left with Q plus 2 times Q plus 7 all over 7. Okay? And then if you wanted to, you could multiply that out. I don't care which way you keep it in this case. You can multiply that out and then get a trinomial again. What's that? Q squared minus 9Q plus 14. You can't simplify the 14 and 7 though. Okay, it's a polynomial. All right. Finally, we have dimensional analysis problems. I'm going to go over these. I think I'm going to have you try them from the homework, and then if you have trouble with them, I'll certainly help you with them tomorrow. But quickly, let's go over I'll give you your homework assignments so you can start working and asking questions if you have any. Okay. Voices are off. I'm going to change this in just a second. It's actually, the assignment's very similar to yesterday. Number-wise.
Drug reference.
You just
Find it really quick. Here, that's.
There you go, move your head.
So what?
You need your plate.
No, I can just get it like shoots with the ball.
Hey,
Like really severe.
can someone grab the lights, please? Thank you.
Grab them, but I don't know if I can turn them on or not.
We're still recording.
Oh, thank you.
We can post that on Class Church.